I'm Brett Norton once again with Beyond Clean, and I would like to thank you all for joining us and hanging in there with us today. It's been a great series of educational sessions as far as water quality is concerned, and I hope you're learning and taking enough away from it to where you can leverage some of this information and really try to hit home on the importance of water quality in your departments. I want to also once again thank our event sponsor, Verta Water Quality Systems, and also First Case for their collaboration and providing our nursing credits for this conference. Our next speaker is Donald Tumminelli. He is the Senior Technical Manager Client Services at High Power Validation and Testing Lab Services. Don has over 20 years of experience in the medical device industry, specializing in developing and validating medical device reprocessing practices. Don sits on over 20 standard committees with AAMI, ANSI, and ISO. And so we'll go ahead and go forward with the presentation title. His title is The Impact of Water Quality on Steam Sterilization Efficacy on Sterile Processing. Sterile processing departments rely on their steam sterilizers to provide sterile patient-ready instrumentation. What happens to the effectiveness of steam sterilization when the department has water quality issues? Don will outline the effects of poor water quality can have on steam sterilization, and he will take a deep dive into the different types of water used during instrument reprocessing and explain the benefits they provide to your instrumentation. So without further ado, let's welcome Don.
Hello, folks. Happy Friday. For that matter, on the East Coast here, happy Friday afternoon. Looks like we're on the last leg of the conference today. I appreciate everyone who's attending. I just want to say thanks also to the Beyond Clean team. They're doing a great job, and I'm honored to be here today. Trying to follow some really good talks earlier today. Everyone's been doing a great job. A little redundancy, but I think that's needed when it comes to water quality. One thing, though, I hope I could do this, but I wanted to, if I could, nominate one of today's slides for best animation, and that goes to Tara Kramer. It was a slide. If you didn't see it earlier, it was a second presentation today. It was pretty good, and it kind of made my day. But as a microbiologist, it was a picture or an animation of a bug or something being stomped on by a couple people, and it was just fantastic. So thanks for giving me a good chuckle there, Tara. All right. So today we're going to get you into some steam quality. Okay, there's a little bit of steam quality talked about today. And it is my presentation. It's high tide and CS. And therefore my background. I hope you're enjoying my background today. I'm at the beach. But the reality is I'm sitting in my office next to a printer and a computer. All right, folks. Well, I do appreciate the introduction earlier. But my name is Don Tumminelli, as mentioned, Senior Technical Manager Client Services here at High Power Validation Labs. For those who don't know who High Power is, we are a contract testing laboratory. We've been validating medical devices well over 30 years now. I've been with High Power about 20 years. Once again, I sit on about 10 committees with AAMI, ANSI, and ISO. AON corporate member and a subject matter expert in sterilization and device reprocessing. High Power is located in Rochester, New York. All right, so today, I'm hoping that when I'm done with this presentation and we're done with the conference, everybody has a good understanding of what is water. Just when you thought maybe you knew what it was, we'll help you understand that a little better. The next is, what is steam quality? And the types of steam quality, along with the critical variables for steam quality. And one of the most important things that I think is going to be a take-home message today is understanding feed water quality. We talked a lot about that earlier in other talks, but then there's I can't stress it enough. The feed water and the incoming water before it gets to your devices, before it gets to your sterilizers, it's very important, and monitoring that is critical. Next is how steam quality can affect your sterilization. And then last but not least, we'll talk a little bit about the types of water for reprocessing. All right, it's always good to know some acronyms. You may know all these, maybe you don't, but I'll go over them real quick. Association for Advancement of Medical Instrumentation is the full name for AMI. IFU, Instructions for Use. Very important to follow those instructions for use, whether it's for your medical device or the instructions for use maybe that come with your equipment that you're using to, in your department, your DI water system. Maybe there's your boiler or your sterilizer for that matter. So it's important to follow those instructions for use. Of course, MDM, medical device manufacturer, okay, and then TR, technical information report. Okay, so standards to talk about as well. I started out with AMI ST8 hospital steam sterilizers. It's important to know that because in there there is steam quality information. The ST8 is a manufacturer's document, so not technically a user's document. So it's what a sterilizer manufacturer would have to conform to get their sterilizer cleared in the U.S. under FDA. Of course, AMI TR34, probably the most talked about standard today, or I should say technical information report, not a standard yet. And of course, we've also talked about the fact that it is on its way to publication, hopefully, under AMI ST108. And, moving from a technical information report, which is just a conglomeration of information on water quality, we're now moving into more of a consensus, okay? And that's really what makes a standard is it's a consensus of a lot of different interest groups all agreeing on the same thing. And at least with a majority, I should say. The TIRs are not scrutinized as much. So when ST108 does come out, you're going to see some of the specifications will be tightened up a little bit and fine-tuned, should I say. AMI ST79 is your comprehensive guide to steam sterilization. I'm sure everybody has this in their CS department. If you don't, you're probably going to want to get a copy. There's some good information in there on steam quality as well as an annex that you're going to want to take a good look at. And if you don't like reading information like that, have your engineering department get involved. And of course, AORN guidelines. So I point these all out because they have to do with steam quality. They do mention it, and there is good, useful information in those. Okay? Okay, now, talking about steam quality, I wanted to stress this out of AMI ST79. Steam quality, when you think of the word, it sounds simple, right? But it's very complicated. As we've heard today, just with water quality in general, it can be very complicated. There's a lot of moving parts. But this excerpt from ST79 kind of puts it into light. I like to think of this as a systems approach, okay? Everything to do with steam quality, everything to do with water quality, it's a systems approach. You don't just rely on one component, okay? Similar to when you release a load from your sterilizer. You don't just rely on the CI or the BI or the printout. It's a systems approach. You're looking at all those pieces of the puzzle to make that final call. And the similar thing happens here with steam quality. You want your system to be able to deliver your steam based on the design of your system, the monitoring, and the maintenance, okay? And the monitoring I can't stress enough because things can change over time, season to season. Municipality to municipality, even different parts of the country. So monitoring and keeping on top of any changes that might occur in your feed water or just your incoming water in general is important to cut off things before they happen. Because we all know that if things get out of hand, they can become very costly. So this little excerpt kind of brings everything into light. Okay, so what is water? We all think we know what water is. We learned it in school, but do you really know what water is? First of all, it's a molecule. It's just 2 hydrogen, 1 oxygen. Covers 71% of the Earth, and it's a universal solvent. Now that right there is a showstopper for me. A universal solvent. So that means that all kinds of minerals, all kinds of chemicals could be in your feed water, in your tap water, in your, whatever water you're using, it's coming into your hospital. Because of that fact, those minerals and those dissolved materials and what have you, sediments, all can wreak havoc. Okay, so it's all about managing what's coming in to the other end, which you could call end to end. Okay, 60% of the human body is made of water. It's critical for life to sustain as we know it, and that comes in many forms: ice, vapor, liquid, snow, and of course, steam. This last bullet's really interesting. Just want to throw this in there for a fun fact. Water becomes less dense as it freezes. Probably a lot of people didn't ever think about this, or maybe you don't know about this. But what's amazing is this. Most things, when they get colder, will shrink. Okay, they'll get smaller. Okay, when they heat up, they get bigger. With water, when it gets closer to the freezing point, it actually expands or becomes less dense. So the reason I point this out is because if it didn't do that and a lake froze over in the winter, that ice would sink to the bottom and you would not have a lot of happy fish. So thank God water does what it does. It's an amazing thing. Okay, now we know water is. We're going to talk about what is steam. It is in essence a gas created from a liquid. Specifically speaking, in the context of this presentation, water. And it's defined in Oxford as the vapor into which water is converted when heated, forming a white mist of minute water droplets in the air. Amy also has a definition, a little different. We expand into the characteristics of steam needed to achieve sterilization. So we look at dryness factors, okay? The weight of the steam, all right? And the level of non-condensable gases. Those are very important for steam quality in a CS department. All right, steam can be ambient. What I mean by that is it can just boil out of a kettle, steam into the air. But in our purposes here, our steam is contained under pressure in a closed chamber. So let's start with the basics. And I heard this earlier, and I'm glad I heard this earlier from somebody else. Garbage in, garbage out. This applies also to water quality and steam quality. So you got bad water in, you're going to have bad steam quality out. You got good water in, you're going to have good steam quality out. Use that as a mantra. Here are some types of steam quality that I'd like to make sure everyone understands. These seem to be the 3 biggest areas that can cause havoc or get you where you need to be. The first one we like to say is a moist or wet steam or elevated moisture. Okay, moisture content's greater than 5%, and dryness factors less than 97%. Number 2 is saturated steam. This is your ideal moisture. This is where you want to be to have good steam in your sterilizer. Your moisture content has to be just about right, and your dryness has to be greater than 97%. Okay, those are the measures they do when you come in and do your steam quality testing, whether you do it in-house, your engineering department does it, or you hire someone, a professional, to come in with a steam quality test kit. This is one of the things they're going to look for is dryness. Very important. Number 3, superheated steam. That is another condition that could be occurring in your sterilizer. We call it, it's also minimal moisture, very low moisture contents, elevated temperatures, and lower pressure. When I say elevated temperatures, lower pressure, temperature and pressure do not correlate. And when that happens, you can end up with this superheated steam situation. I like to equate it to dry heat, a dry heat situation. Where we used to see it many years ago was when hospitals used to sterilize large amounts of textiles or large amounts of towel packs. When that steam gets introduced into your sterilizer, those textiles sort of absorb or take in a lot of the steam, and you lose a lot of some of the energy, and hence you end up with this drier heat environment, which we call superheating. Okay, like I said, garbage in, garbage out. Feed water. feed water going into your boiler. Very important. This table right here came courtesy of Columbia Boiler. This came off one of the boilers we actually have here at High Power. Our lab has well over 50 sterilizers in-house, many of them low temperature. We do have a large steam or high temperature department as well. And we use house steam. And house steam is a boiler that's not located right next to the sterilizer. It's usually used for multiple steam devices. So all of our steam sterilizers all use house steam from a Columbia boiler. Now, the boiler manufacturer has this information right on the plaque on the boiler. And we do contract the maintenance with them, which is good. So these are their recommendations for their boiler because they make it and it's under their warranty. Now, you'll notice already today we've seen some other tables, some right out of TIR 34. And hopefully when 108 is published, we will see those final numbers that we need to comply with in your CS department. So this is the struggle I think that some of us end up with is kind of juggling the pieces of equipment that we may have, like the boiler. The boiler manufacturer, who may have a warranty on it, wants to see these numbers here, whereas down the line, we may have to have other numbers. So it is complicated, and it is something that you have to juggle and make decisions on based on the outcome of what's happening to your devices when they come out of the steam sterilizer, okay? Things may have to be adjusted. pH, total alkalinity, phosphates, hardness. Those things may have to be tweaked based on your system, okay? Every system may work a little differently. I did highlight the chlorides because I'm pretty sure that 108, when that is published, I do believe that one was a good topic of discussion. I believe it's going to be less than 100 if I'm not mistaken. But someone can fact check me on that. I just want to throw this out there. If according to this table here, we do follow this and we do meet these specifications and we do end up with really good steam in our sterilizers when we do our steam quality testing. Let's talk about non-condensable gases. You may or may not have heard non-condensable gases, but they can be problematic in your steam quality. Keep in mind, the non-condensable gases apply to our application here, which is steam. Okay, and it is condensable water vapor. Non-condensable gases are gases that cannot be condensed. Okay, so if your feed line water or your feed water has impurities or chemicals which can't be condensed, we simplistically talk about them basically as air. And we all know that air can be an insulator, okay? And so the last thing you want in your steam is non-condensable gases, which could create air pockets or other areas in the chamber where your steam is not at its highest energy level and could affect your chemical indicators and your biological indicators. I think, with non-condensable gases, I think the biggest monitoring device that is affected, which is probably going to be your buoy dig test pack. It's always not a vacuum leak that can affect your buoy dig test pack. It's also non-condensable gases. So if you are investigating, failed buoy dig test packs, maybe one of the things you want to investigate is non-condensable gases coming in through either your feed water or some other method. Okay. It's well known that residual air, non-condensable gases, act as insulators, which in essence is a barrier. So things like in your water quality, like additives such as anti-foaming agents, should be used in the proper dosage. That's the key thing right there. If you're going to use these things, you have to use them in the proper dosages. Okay, they could help non-condensable gases. Like I said, it's something you'll have to decide with your facility if that's something that you need to do. All right, non-condensable gases. So, what can be done? Well, one way to do it is water softeners. I think earlier there was quite a bit of talk on water softeners. It's great if you have hard water. We saw some nice maps of the country. Those look like really nice maps. I'll have to get my hands on one of those. which kind of went over the hardness that's found around the country. Looked like a lot of red in the middle of the country. So you may need to make sure that your water softeners are adjusted for those hard water conditions, depending where you are in the country. Another big thing is boiler blowdowns. Okay, so here in our lab, we do daily blowdowns with our boilers. It is a lot of work. We feel it's important to do that. Maintaining a sterilizer and having problems with devices down the line with bad water quality or bad steam quality, that's one thing. But the last thing you want to do is have your boiler basically out of service, especially if it's a house steam boiler. If your house steam boiler goes down, you may lose access or availability of all those sterilizers that might be supplied by that boiler. So we think it's really important that that boiler is maintained and running perfectly. One of the big things the blowdown has helped us with is our heater elements in the boilers. We have extended the life on those dramatically by doing the blowdowns. Whereas years ago, we'd be changing out heater elements quite often, maybe every 1 or 2 years. They are high voltage heater elements, and years ago, before we were doing this and properly maintaining the boilers and the water quality in the boiler, the heater elements, if you pull them out, a lot of them are U-shaped, okay? And there's a space between them. Well, I remember myself taking these things apart and pulling out the old heater elements, and it was one solid chunk of whatever, minerals deposits. And so basically, in essence, it shorted out on itself. So to avoid those expensive repairs, take care of your boiler. Okay, don't forget that. The other thing, too, is use water treatment additives, once again, like anti-foaming and oxygen scavenging, once again, in proper doses, okay? I always say, you could attempt to control your water quality system yourself in-house. Many bigger and larger facilities may have the capability to do that. They may have the expertise in their engineering departments. That's great. But I always recommend contracting out to the experts, letting them handle that, and frees other people up for more important things. Another thing you could do is off-gassing feed water in a vented tank, or possibly have a hot well. All right, so steam quality again. How does steam quality affect sterilization? Well, if you have moist or wet steam, that could lead to wet packs, okay? Overloading sterilizers, probably the leading cause of wet packs, but moist, wet steam is also a contributor or a variable that you want to consider for wet packs. Inaccurate BI and CI results, okay, can be affected by moist or wet steam. So if your steam is not at the ideal steam dryness, okay, or your non-condensable gases are uncontrolled, yes, you could end up with BI and CI results. Most BI and CI manufacturers are validating the BI and CI with the proper steam quality, okay? So those BIs and CIs are operating and working the way they are intended by the manufacturers, and if you're not using a similar steam quality as them or up to par with your steam quality, you could have those inaccurate results coming off your BI or your CI. Of course, you can also get uneven temperature distribution within your chamber and load, which is not a good thing. And superheated steam can also lead to inaccurate BI and CI results because biological indicators, as you know, they're spores, most of them, and they need that high energy saturated steam in a steam environment to achieve your kill on those. So if you get into this dry heat environment, dry heat sterilizers take much longer to achieve sterilization. So with a superheated situation, I wouldn't be surprised if you did have failed BIs. You can also fail the sterilization cycle itself. If your temperature fluctuates in the chamber, it could abort with a high temperature alarm, and that's not a good thing as well. Scorching and accelerated degradation of devices. How does poor steam quality affect medical devices? You can also get pitting, which we talked about earlier. Certain materials can react with impurities in the steam to cause little cracks and crevices and pits on the device surface itself, which eventually leads to a more difficult to clean and a more difficult to sterilize device. Staining, which is discoloring of materials on the surface of the device. Most of the time, staining is irreversible. Once it occurs, it sometimes or most of the time could lead to discarding that device if you can't solve the problem. Spotting, residual dissolved impurities on the device itself. And depending on the spotting, you could help investigate different impurities in your water quality. Okay, so different colors on the device are instrumental in helping you investigate what might be causing the problem, what impurity is in your water. Corrosion. This is a chemical reaction which causes the materials to degrade. Once again, similar to pitting, once corrosion occurs, it's almost non-reversible. One of the things, skipping down there to 2 bullets down to laser etching, that ties in with corrosion. A lot of these, I don't know if you're familiar, but UDI is unique device identifier markings. Most manufacturers have to be in compliance with that nowadays. That's for device traceability. Many CS departments may see devices that are coming in with QR codes on them now. You may have readers in your department for tracking. A lot of those are laser etched. And what we found is with bad steam quality, the laser etching and the UDI markings just will not hold up. They will corrode around the laser marking and laser etching, depending on how the laser etching is applied to the device. Another thing that could happen is your count sheets or any labels that you might have. They may not stay affixed. Your labels may dislodge from your device on a wrap pack. Your tape could be affected. Okay, so lots of things could be affected with your poor steam quality. And then, of course, sharps and edges could be etched and degraded with bad steam quality. Okay, so what are some causes of poor steam quality? Well, excessive demand on your steam supply. Okay, if your boilers are constantly running, constantly trying to keep up, you could actually end up with a situation where your steam quality is not ideal. Dead ends or dead legs, we saw some pictures of those earlier on your steam lines. So this is your systems approach, once again, checking out, making sure your engineers understand how a system is set up. Amy SD79 has some great information in their facility design to make sure that you don't have dead ends on your steam lines. Improper installation of the steam lines. We talked earlier about how house boilers or large boilers could be long distances away from your sterilizers. The longer you're away from your sterilizer, the greater the risk or the increase in risk that your steam quality is not going to be so good. Excessive distances are a problem. The other thing too is underrated or undersized steam generators. Okay, it's really important that if you open up your facility and you have maybe 2 sterilizers and you have a generator or a boiler that was installed, you may expand and install maybe 2 more steam sterilizers. But don't forget though that that steam generator may not be enough for all 4 sterilizers, and that could create a situation where you end up with not so ideal steam quality. Dirty or malfunctioning steam traps on your sterilizer, probably one of the number 1 issues with bad steam quality. Make sure those steam traps are being cleaned. Very important. And the water quality itself coming in. And lastly, boiler water level. Make sure your level's incorrect or not too high. You want to have a good head of steam in your generator to keep that high energy going. If the head of steam isn't good enough or at the right levels, it's not going to move down those pipes and into your steam sterilizer in the same quality that you want it to. Usually in that situation, it could be as easy as a float valve being adjusted. All right, more about what causes poor steam quality. Priming or foaming within the boiler. Okay, this does happen. It could be caused by improperly treated feed water once again. It could be because the boiler water level is too high, or you have a high level of dissolved solids which end up in your boiler. And once again, improper boiler cleaning. So maintaining that boiler, it's important. It's at the front end of the system, so keep your boiler happy and hopefully keep everything else down the line happy. Okay, how do we improve steam quality? Well, ST79 has some great ideas. Section 3333 has some good information on maintaining the purity and minimizing the presence of potential contaminants in the steam. Once again, get together with your facility engineering department to help troubleshoot steam quality. One of the things you can do is treat the feed water with boiler additives, as we mentioned earlier. And then if you're going to do that, make sure you're monitoring those boiler additives and your feed water conditionings. Once again, monitoring. Monitor, monitor, monitor. I can't say it enough, guys. You know, just because you may get something exactly where you want it today doesn't mean that 2 weeks from now there wasn't some change in your municipality water that's coming in, or some other change in the system, or sloughing off of biofilms, or anything like that that could affect or change everything you worked for over the last few months. So keep monitoring, very important. Next one down, use only additives and conditioners, okay, that are approved by the FDA. The last thing you want to do is use some toxic additive that could end up on your device at the end of the day, causing a cytotoxic or biocompatibility response with the patient, okay? So it's important that you're just not dumping anything in there and that you're actually following the right guidelines to make sure you have safe additives. Another thing you do is you can install inline filters as close to the sterilizer as possible. I know a lot of systems have filtration systems, carbon filters up front, all the way up to UV systems and other filtration systems for sediment. Make sure you develop procedures to monitor your steam purity and provide corrective action if needed. Amy says facilities should not use boiler additives and feed water conditions on a batch basis. It also says to add boiler additives or feed water conditions to the steam distribution system. And do not use amines for conditioning steam lines. All right, what else can be done? So what can you do for feed water quality? Once again, water softeners. Sometimes reverse osmosis systems work. Assure you're meeting those water quality specifications. You have those tables. Those are all recommended, and hopefully 108 will clarify that for the rest of the industry. Of course, once AMI 108 comes out, it's obviously going to be something that your notified bodies or your regulatory agencies, maybe Joint Commission or CMS, are going to take that a lot more serious now that it's a standard. They may hold you to some of those, but they are recommendations, so use it as guidelines. Maybe you have to set your own specifications. But whatever those specifications are, if you set them yourself, you need to follow them, and you need to monitor them. Make sure you keep meeting them. So other things you can do for your feed water quality is storage settling tanks. You can also have vented hot well for off-gassing. And then, of course, pH. A lot of us talked about pH today. Make sure you are meeting the correct pH levels for your sterilizer. You don't want them too acidic, and you don't want them too alkaline. For your facility design, you can assure the shortest, most direct steam route from the boiler to the chamber. Once again, clean those steam traps. Add your water treatment additives. Insulate your steam lines. Avoid dead legs. And assure condensate flows by gravity are the same direction as the steam. There's more information about that in AME 79 if you're curious what that means. And by all means, check your steam quality. If you don't have the means to do that, there are companies out there you can hire. They will come in and check your steam quality for you. Very important. And speaking of steam quality, I just had to throw a picture in there of a steam quality test kit. I had the joy of using these many, many years ago. They're not fun. I hope I never have to use another one again. We have experts to do it, so I advise the same to you as well. All right, so facilities should have a system for steam delivery that's designed, monitored, keyword, and maintained to ensure that the quality, purity, and quantity of the steam provided are appropriate for effective sterile processing. AME 79, ARN, and other standards offer guidance for the proper facility design. Great resources. Okay. That's it for steam quality. I'm going to give you a little bonus content here. It looks like a lot of this was covered earlier, but we're going to talk a little bit more about, for those maybe who didn't see the earlier talks, we're going to talk a little bit about water quality for cleaning. Two types of water quality, according to AME TR 34, utility water and critical water. And currently speaking, those are the two types. I do believe that ST 108 may add a third called clean steam. I won't talk too much about that right now because I'm still learning about that myself. But for utility water, it is water as it comes from the tap that might require further treatment to achieve the right specifications. Okay, so this water is mainly used for flushing, washing, and rinsing, okay? That's utility water. Critical water. This water is taken to the next level. It's water that is extensively treated, usually by a multi-step approach, okay? Could use a carbon bed, could use softening, DI water, RO water, or distillation. Okay, this ensures that microorganisms and inorganic or organic material are removed from the water. You can also have a final submicron filtration in your system. This type of water is mainly used for your final rinse or for your steam generation. I'm really looking forward to the publication of 108. I think it's going to clarify a lot for the industry, and I think it's going to help a lot of healthcare facilities understand what they really need to do now. Okay, so why is water quality important for cleaning? Well, it assures that your cleaning agents perform as intended. Many of the cleaning agents, whether they're enzymatics or anionics or alkalines or what have you, they will have on their instructions for use the water quality that is required or recommended to be used with the proper dosages of those cleaning agents. So if you want your cleaning agents to do what they're intended to do, make sure you're using the correct water quality that's intended to be used with that. It's also important to control microbial limits, endotoxins. We heard a lot about endotoxins today. It's very important. It's becoming a bigger topic in the industry. More regulatory agencies are focusing on endotoxins. It falls in the world of biocompatibility, but it is important that we're also controlling that. To assure proper removal of cleaning agents in the final rinse. Okay, so water quality affects your final rinse water. The reason I bring that up is because during your final rinse, you want to remove any of those agents off the device itself. Currently speaking, one of the analyses that we do here to prove that in our validation testing is kind of an indirect way of testing residual detergents, and that's via a cytotox analysis. So we have seen situations where certain agents are not cleaned off the device, and that agent will interfere with the cytotoxin, and you will end up with a cytotox response. So it is important that you do follow the correct water quality for that cleaning agent to assure that it is removed off of the device before it ends up in the patient or on the patient. One other thing to point out, the importance of water quality and cleaning is to protect your equipment, your automated washer, your AER, okay? Once again, just like your boiler, if you're following the right requirements or the right recommendations by these manufacturers, you're going to extend the useful life of this equipment, bring down the cost of costly repairs. Okay, in the world of cleaning, we know there's different ways to clean things. In the world of manual cleaning, tap water may be used if it meets the minimum requirement for utility water. Okay. The temperature of the water during manual cleaning should not exceed 45 degrees to prevent coagulation. A lot of you might not think temperature is an aspect of water quality, but it really is an aspect of water quality, and it should not be ignored. Once again, many of the cleaning agents on their instructions for use will tell you, don't exceed certain temperatures. If you want that cleaning agent or any other agent for that matter to work properly, make sure there's not a temperature requirement on there and you don't exceed that temperature requirement, or you're not too low with that temperature requirement. You want that agent to work as it was intended to be used. Tap water is often okay for rinsing unless the device comes in contact with your bloodstream. Then you need to use critical water. And whatever water is used for your final rinse, it should not leave residuals, as mentioned earlier, that could prevent further reprocessing or patient safety concerns, typically cytotoxic responses. And there's automated cleaning. Typically, automated cleaners have two water inlets for cold and hot water. The hotter the water and the steam generator will help your heater elements. Water quality should be compatible with the devices being reprocessed. Okay, so follow those IFUs. Look in the IFUs for the automated cleaning sections. Make sure you get the right temperatures in there. Make sure you get the right dosing with your detergents in your automated washer. And then once again, make sure that water quality is compatible. Water quality factors for washers. You're going to want to look at hardness, pH levels, temperature, chloride and heavy metals, microbial levels, and once again, endotoxins. And this is just a little more about endotoxins. We talked about earlier, or the other folks talked a lot earlier about endotoxins, pretty much derived from gram-negative bacteria. But the definition is, it is a toxin that is present inside a bacterial cell and is released when the cell disintegrates or lyses. It is sometimes responsible for the characteristic symptoms of diseases in botulism and could lead to pyrogenic responses or fevers. Endotoxins can be present in your utility water. Okay, so if your microbial levels are too high or just you have the wrong organism in there, you could end up with endotoxin in your utility water. So it's important to assure final rinse water for devices in contact with the bloodstream are endotoxin free. We have a lot of different waters here at High Power. We've worked with distilled water, deionized water, irrigation water, on and on and on. All right. So if you felt like this before the presentation or at the beginning of the day today watching some of these presentations, I'm hoping you now feel like this, a little bit straightened out. Thanks, everyone. Any questions?
All right, Don, thanks. That was great. I think, steam is one of those things that, is talked about frequently, but not really, I guess there's not a lot of detail when you're talking steam. And I first wanted to ask you a really important question is, where's your Hawaiian shirt with your background?
Yeah, you guys like that background? Yeah. You mentioned earlier, you reminded me earlier that I did have this background and I did the last talk with you guys. So
yeah. Well, and I think it was on a Friday too, and we were talking about having Coronas on the beach. So goes well. So one of the things that I thought about while you were presenting this was the concept of clean steam. And I know that that's a term that's thrown out a lot. And I know that there are people that say not to use the term. And I just wanted to get your kind of insight on what you think and maybe your definition of clean steam, if you will.
Yeah, no, I'm actually still learning a little bit about that myself. I saw it in a presentation earlier today. Unfortunately, I did miss some of the 108 meetings, so conversation on clean steam, I don't recall any of that. I think we're going to have to point to some of the experts, possibly John Wilder,
Right.
who is
Okay.
a frequent fan of your show.
Right. Yeah. We love having John on. He's great. So I was also thinking, if you've got if you have a sound water quality system in place and it's good at the sink, you've got the testing and everything is all well and good, and all the way through, the sink, ultrasonic, into the washer disinfector, and then you get into steam sterilization, and then the steam is compromised. So just a hypothetical,
Right.
what, how would that happen? Or, the two systems, I think, you did mention that things are good to be working in conjunction as a system. But if that happened, you get all the way to the end and then the steam is compromised, how is that a problem?
Well, yeah, you're right. Even though it's a systems approach, you can maybe look at it in phases as well, right? You have different phases that are happening, right? And different water qualities that's happening in different parts of those phases. It's almost like the wash disinfector has what you need for its water quality when it goes into the wash disinfector, and everything's great up to that point. But if you get into the steam quality, you now could be compromising sterility itself, right? Killing the microorganisms. Because that is the intent of the sterilizer, is to kill the microorganisms. The intent of the washers, obviously, is to clean the devices. And the definition of cleaning is physical removal of soil. But
Right.
we have to remember one other thing that a lot of us didn't talk about today, and that's disinfection, too.
Mm-hmm.
I mean, there are some devices that don't require sterilization as an end before
Right.
patient use.
Yep.
You could stop at disinfection, either intermediate level, low level, or for the matter, high level. So I think in every one of those, if may want to break them apart into phases, maybe, they have their own intimate water quality requirements that you have to meet. So at the end of the day, you're right. It's almost like a cumulative approach, right? You add all the phases up, and what's the end result, right? So could one of those phases break down? Sure. You could have everything great up until steam quality, and now you have a steam quality problem.
Right. And then my question...
Could that affect the degradation of the device, correct? Oh, yeah. Mm-hmm.
Yeah. And then my question would be, how do you test that? It could be like you said, it could be from the beginning of the process, or it could be the end. So then you end up having to test. I guess you have to bring it all together. And
sure.
Yeah.
Yeah, so if you're doing an investigation, so I think I see what you're saying. So you're saying you open up your sterilizer door, you pull out your devices, and you have spotting or staining. Where's that coming from? Is it coming from your steam quality? Is it coming from your feed water? Is it in your boiler? Where is this coming from? Is it in your washer? It's a lot of things to look at, and it's complicated. But if you did a deep dive investigation, it could take some time. It could really take some time. You could do it a couple of different ways. You can work backwards, which I've done that before. You work backwards. You rule out the steam first, and then you move back to maybe your washer disinfector, maybe your manual cleaning, and maybe your feed water.
Right. Well, and I think that's a good point, is that working backwards, finding, when you're at the sterilization point of cleaning instruments, that's ultimately the most important, because you want sterile instruments for the OR. And so if it's bad there, then you can probably figure out that, yes, it's not working here and could not be working at the other stages. So, complicated process.
The interesting thing here, the interesting thing here is, we're talking reusable devices today, but I think Tara touched a little bit on this earlier. Single-use devices, devices that enter the healthcare facility sterile, right, to be used, okay? There's a medical device manufacturer, or an MDM, the acronym I used earlier. They're fully responsible for all of that, okay, at their facility where they're manufacturing these devices. For them, it's a little easier to control everything, right? They're controlling everything throughout the whole process. So when that device enters the healthcare facility, it's ready to be used. When you get into, reusable devices, it becomes much more complicated when it comes to controlling water quality, right? Because there's so many variables at play, okay? That device is touching so many different hands, so many different departments. It's not just going down an assembly line and following all the processes the same exact way every time. So there's a whole other world out there, guys. There's one with the reusable devices. That's our challenge right here for trying to figure this out. But like Tara mentioned earlier, in the single device world, you still have to follow all that. You still have to have good steam quality. All that has to be achieved, but it is, I think, a little more controlled.
Right. No, that's a good answer. And, as you mentioned in your presentation, monitor. And that's, I think it's so important because we have touched on that multiple times today, that it's not just a plug and play. And you mentioned in your presentation as well that you don't just test it one day and assume that it's going to be good the next. And it's important to have a repetitive process in place. And you talked about having somebody there to, having a contractor there to help a department through the process. And so maybe you could talk a little bit more about that in terms of the level of contracting, because you think about departments that have, budgets that are very limited, especially sterile processing. And so it's hard to really map that out. And obviously Alpa talked about it in her presentation as far as, gathering that information and working with the C-suite to try and, have a good system in place. But do you have some info on, the type of...
So I'll tell you, based on my experience here, every company, every healthcare facility evolves over time, right? So I think back at, 20 years ago when I first started working for High Power, we were much smaller. And we were doing everything ourselves. We wore a lot of hats around here. So when it came to water quality, steam quality, and all of that, we were doing it all ourselves. But it gets to a point where it becomes unmanageable, right? And that's not good for anybody. It's not good for us, not good for our customers, and for that matter, it's not good for patients. So we decided, we need to stay focused on what we're supposed to be doing here, right? What's our specialty? And so therefore, we now have a water company, it's called WaterWise or local. They come in and they manage all of our water quality to our specifications. And they're the ones who are doing that, and they're coming in quite often. We have a contract with them, so that's one thing. The boiler, we also have the manufacturer of the boiler. They come in and they do all the PMs, they do everything. So we decided it was in our best interest to let them manage all that. That's what they do for a living. And I know that's not a good fit for everyone out there, smaller facilities, bigger facilities. It may not be in your budget, but it did seem to work for us. And we now feel like we do have them fully under control.
Yeah, and I think it's a good point that having somebody that's an expert in the monitoring and the maintenance of it, because ultimately down the road it becomes more expensive if it becomes a patient safety issue, or if you've got instrumentation that is constantly damaged and not able to be used, and your trays are shorted. And so it's one of those things that, yes, it might be an extra bill in the mail, but it's going to save you a long-term headache. I think it's maintenance wise is just, and upkeep overall is just a good practice to get into. And I think there's a lot of buy-in when it comes to the economics of saying, hey, if we don't do this, we're going to be paying this.
Right. So, I think, that is a good sell to your managers, right? The people who cut the checks and all that, or make the decisions. I think that's a great sell. If you can demonstrate that the cost to have contractors come in and help you with this, or supplement you with this somehow, I think that it's going to be an easy sell to them, to show them that, our boiler's not going to go down, right? Unless you have a backup house boiler. If that boiler goes down and you can't get someone in to fix it right away, that's going to cause a lot of havoc with you. You can't run your steam sterilizers. You're dead. You're dead in the water. I'm sure it's happened. It's happened to us here. We actually now have a secondary boiler. We have 2 now. So if that ever happens, we have a backup. So now I know not every facility can probably have a backup, but it is a good idea to have that too. But yeah, if you can go back to your managers and your decision makers and make that case to them, you kind of lift some of that off your shoulders,
Right.
And put that on the people who do this for a living.
Yep, exactly. And instruments, as you know, are not cheap, and you want to make sure that you're maintaining the instruments and that they're at the highest quality. And then you get into talking about scopes. Scopes are a whole nother ball game with the price tag on those. So
I'm sure one canceled case pays for those contractors.
Yep. Yeah.
One hip surgery that could pay for your contractors for a whole year right there. So think of it that way.
There you go. All right. Let me get into some questions from the audience before we jump off. We've got about 5 minutes or so. So how often do you suggest testing the steam condensate?
Well, that's a good question. I would recommend, if you're just starting out and you have no information or no data on your facility, okay, so say you're starting from scratch and trying to figure this out, you might want to try it monthly, dial it in, see what you got. If you're way out in left field, you're probably going to want to do it more frequently. And then you can basically adjust based on the data you start receiving. So if you do it monthly, maybe for the first few months, and there's no skewing, there's no variation, everything seems to be level, you could probably back off on that. You might do it every 6 months, maybe yearly. But I think it's going to depend on your facility and the data that you bring in when you start doing it.
Great. Awesome. And then we've had some good comments here. Really enjoyed the presentation. And all of the sessions today have been very good and educational. I do have one. Let's see here. Where else? Are there recommendations for distance between the steam route from boiler to chamber?
Great question. You know what? I have not seen any hard numbers anywhere other than recommendations to minimize it. Let me just give you guys an example. If there's people out there in the New York City area, I did some investigating out there at some hospitals out there. It was a wet pack concern. During my investigation, I found out that their house steam was literally a block away. The steam went underneath the street, and I can't remember which avenue it was in New York City. Went underneath so it went from one building underneath the street all the way up to the next building. I mean, we're talking, I don't know, it had to be hundreds of yards.
Yeah.
And that was a big factor because we found out that a lot of the line was not insulated. So as you trace that backwards, I would say about 50% of the lines were not insulated. I mean, you're taking that steam you got all this great steam quality hundreds of yards away, right? They were doing the steam quality testing at the point of the steam generation, which was a block away. Everything looked great there. Nobody ever thought to do the steam quality at the point of use where it went into the sterilizer. Once they started doing a steam quality test, they noticed it was way off just from going a few hundred yards. So just because you were testing at the boiler was one thing, but that long distance something was happening to the pipes, Right. There's just all kinds of variables that can affect your steam quality. And the longer the lines are, the bigger the risk of the steam quality degrading over time.
Right. Yeah. And, you mentioned pipes, being that the steam would have to travel that distance. Mm-hmm. In terms of the metal makeup of a pipe, you've got your coppers, you've got your PVC.
Sure.
What is your recommendation when it comes to steam?
Oh boy. So, I mean, there are different manufacturers have different specifications. You will see some of them out there using brass. You'll see a lot of them some of them use stainless steel. I've seen a lot of European sterilizers using stainless steel. I am not a sterilizer manufacturer, so I don't know all the ins and outs of why they choose the materials they choose. But, I can tell you that some of those materials are problematic, okay? Some coppers can be problematic. It also depends how the design of the piping is, right? We've seen that as well. It may not just be the material, it's just how the steam moves through the pipes. The more bends, more turns, the more problematic it could be.
And as you mentioned, if there's a dead end, then that's a whole nother ball game, because then the steam's not moving and not free flowing, as we talked about today. So, well, Don, I think we are at time, and always good to chat with you. Good to see you on the beach there, enjoying yourself out east, and really do appreciate everyone once again for joining us. We've got one more discussion. It's a panel discussion hosted once again by Bobby Parker from our team. So please stick around for one last go, and then you'll be directed right to the page to get your CEs for today's event. And Don, once again, thanks for joining us. Appreciate you putting in the time, and it's been great working with you through the process, and I'm sure we'll be seeing you soon.
All right. Enjoy, folks. Have a good day.
Thank you.